An important part of protecting our software is to know what software we have. This is especially important when we're dealing with third-party software and things like shadow IT, and really a lack of control that many organizations struggle with, of not even knowing what applications are being used in what places. We need to document the supply chain that says what software are we using. And one of the things that has been helpful for this in the past is a cloud access security broker, where we can actually then monitor for which applications are calling out to the cloud and being able to, in some cases, get a handle on whether or not different applications have been installed that we're not even aware of in an IT perspective. Make sure we're running the right versions of the software. Now, with the cloud, this is often easier because with software as a service, we see that the actual software as a service provider is pushing out the new versions. So the next time a person logs in, they're automatically using that new version. But in other cases, with platform as a service or infrastructure as a service, we may need to make sure those versions are all up to date on all of the machines of all the users who could be spread out globally that are using our systems. One of the things I think is useful to do is run a discovery scanner. Quite simply, we run a scan to see what's on our network, what is connected as far as hardware, software, so we actually get a picture of what our area of responsibility is. And it's very often quite surprising when we see things that, well, servers and so on that we've forgotten about even, and applications that we weren't aware of. It is good to run compliance scanners to just check to make sure that people's antivirus and operating systems are up to date, for example. Make sure that their configuration of their hardware, their laptops, and in the case of a mobile with mobile device management, that we are compliant with the latest versions so that we're able to hopefully at least cut off a lot of the problems we could have of not running current versions. The challenges we face are often integration. We buy something from one vendor that doesn't really play well with other vendors. It doesn't speak the same language. It's not in the same format. I'm old enough to remember when we had to always deal with conversions from ASCII to EBCDC, and we don't really deal with that as much anymore. But integrating different file formats and date fields, do we do day, month, year, day, year, month, day? All of these are challenges we can face, and depending on where our software is written, does it use a decimal place, or does it use a comma where we're dealing with differences between dollars and cents, for example? We are always dealing with the challenge that the underlying infrastructure can change as well. There can be changes in the operating system and functionality and security of the operating system that can affect how some of our software works. We've even seen cases where there's been improvements in security to operating systems that disabled some of the applications that were running on the system. It could well be there's changes to our business process and we've bought this software, and getting it customized or tailored to meet our new regulations or business process could be extremely expensive and not very fast either. When we're dealing with new regulations that requires a new reporting, and maybe our software doesn't even have the ability to capture or log that information for us. When we're dealing with a third party, sometimes the hardest part is getting good documentation that defines what does the system do and how does it work. And that documentation may have been written for an older version, but hasn't been kept up to date with what we have today. It could be the documentation was not complete for some additional functionality, for example, but we also need to know who do we contact if there's any type of a problem. Who is it that is the liaison or the person we can reach out to if we're having a problem, or need to know if we can make adjustments to the software as well. The software supply chain needs to be attentive to things like licensing, that I'm not committing software piracy, so I know how many versions and copies of the software I'm using. I'm tracking how many units it's currently deployed on, but that becomes a little bit more difficult when the same user might have it on a laptop and a desktop. Well, is that allowed as long as that one user isn't using it on both those machines at the same time? We have to know what the licensing agreements are. It's always a good idea to keep a copy of invoices or proof of payment. We don't want where all of a sudden a software copyright alliance comes around and says, hey, wait a second, you're using 100 copies, you only paid for 80. And since maybe some of these were bought locally, we don't have an invoice available that actually proves we did pay for all 100. So it's important to have some tracking here of our licenses and what we paid for, where the software is being used. And of course, when we talk about the licenses, is it a user license or a corporate license? And these can be very different as far as, well, is it limited to one user or can be used by different users within the corporation, maybe not at the same time. But knowing what the license rules are is important here. When we look at software supply chain, a very important part of this is, where does the software actually come from? We've seen a lot of concerns about this lately, that I don't want to necessarily buy hardware or software that I don't know what was built into that software? Is there undocumented functionality? Now, this is incredibly difficult. We take something like even an automobile or a software for an aircraft. It's not just one piece of software, it's many different submodules. Every sensor in that car is maybe written by a different manufacturer that feeds into a common point of monitoring, but those submodules might have been written 20 years ago. And we've often seen that they were not built for today's world. We don't see them because they're in a component we purchased this sensor, for example. And a lot of them really are based on old code. This is why we often have to look at, well, two things. First of all, here's software composition analysis. What are the components that make up our software, the composition of our software? And identifying all of those different submodules that are in our software to make sure that, wait a second, are these things even secure? Those supporting software components also include things like compilers, drivers, utilities, the configurations of systems such as our network and our underlying platform, and of course our database, everything from the database configuration, the layout, the schemas, to the database management system. All of these make up what we can call that second part of software composition analysis, and that is our software bill of materials. This is something that's getting a lot more attention these days, where we identify all of the components and subcomponents of our software to know what are the pieces that were integrated into our system, and are we even licensed to use them in the way we're using them? Were those components tested? And in some cases, that means testing the source code, but testing the binary to see how that software actually operates as well. When we're dealing with the security of third-party software, we also have to monitor what's going on. Have there been reports of new vulnerabilities? Have there been changes to functionality that the software adds in? And it could be that we've seen this in many cases. They added in some functionality to software that was originally secure, but that new functionality opened up new attack vectors and new vulnerabilities. We must monitor for any threats that if I'm using this software and all of a sudden the news is all about there's problems with this, I need to quickly and thoroughly check, am I using that? Am I vulnerable to this breach? And we've seen this with all sorts of MOVEit and SolarWinds and all these tools that we thought in many cases were pretty good, and found out that unfortunately many companies were compromised because of these products that they were using. With software support, we need regular maintenance and support, often from the vendor, who will then make sure that they're updating and patching software and vulnerabilities are found. It could be we have a local representative that will deal with any types of issues or problems we have. But many of us have also benefited from user groups. We can go on to a chat where people that are using this software say, this is a solution I have found with this problem, and so on as well. Now with those, you have to be really careful. If you're going to use and be part of a user group that says we all use this software, it could be a really good idea to use an anonymous type of email address, not your corporate email address, because if you use the corporate email address to sign up and everybody knows what types of software you're using, and it can be good when people don't know what our software is. There is a bit of a privacy issue there. The idea of open source is great. Everybody collaborates, works together and finds problems and fixes them. But we've seen this with everything from OpenSSL and Heartbleed to the fact that in many cases the problems weren't found. Everybody just thought that somebody else was testing it and making sure it was working okay. So we do have to watch out for that as well. In reality, we should only use something if we know it has been tested or can test it ourselves. I do like what a number of companies do now is they actually offer rewards. Hey, see if you can break into our system, and if you find some type of a bug, we'll pay you for that. And that bug bounty, and a number of very large organizations have paid out a lot of money for that over the years. And people, instead of being a black hat hacker that tries to break things, they rather become what we call some type of a gray or even white hat, that they look for problems and report them so they can be fixed. Key points review. The only way to ensure the security of third-party software is to test it. That is, know what software you're using, where it comes from, and make sure that we only use authorized software that we've been able to test and ensure its security and reliability.